Okay. So what I mean by that, like let's do one. If I was taking a look at a vector and it was vector -1, 2, if it was written this way, all that means is it starts at 0, 0, and it ends at -1, 2. A picture of that vector then would be like this. Okay. Now, what if I have points? Like, what if I give you the ordered pairs, though? Like, let's say it was like the one we did in the last example where it didn't start at 0, 0, and I wanted to find its component form. So, if you are, I'm going to give you a little formula to do that. If you have initial point, we'll say x1, y1, and terminal point x2, y2, I'm going to put a box around this. I'm going to write finding component form, so you understand what I'm writing here. So if I know the 2 points and I wanted to find the component form, all I would do is I do terminal minus initial. So the component form then would be this. Component form. That first coordinate, I would just subtract the x's to get. Notice I did terminal minus initial. And to find the second component, I would just subtract the y's to get that. That's how you get to component form when you have 2 points. Okay. Would you guys like to see an example of that? Okay. I don't know how much of this you've had, so let's find the component form of vector v with initial point -2, 3, and terminal point -1, -5. Okay, so I hope this makes logical sense. The first component is all it's saying is, hey, how far did I go over? How far did I go to the right or left from the first point to the second point? So does it make sense that you're subtracting the x-coordinates to get that? If I wanted to know how far over, isn't x-coordinates left to right? And what's y-coordinates going to tell you then? Up and down. Okay, so I am going to do my component form. I am going to do the terminal x point, which is 1, minus the initial x point, so that's going to be 1 minus a -2. And that's going to tell me the horizontal component. We call the first one the horizontal component. And then for my vertical component, I'm going to take -5 minus 3. All right, so let's simplify that. What would the horizontal component be then? 3. And then what about this? -8. Okay, Now let me tell you what that tells us. All that means is from here to here, it went 3 to the right and down 8. That's what it means. To get from the initial point to the terminal point, we went 3 to the right and down 8. But when we draw this vector, we actually are taking it, remember how I said, and we're dragging it to 0, 0. So if I would graph this in standard form, it's like I would drag this vector that started here and ended here, and I would make it, let's see, 3, negative 8 would be down here. So that's what that vector would look like. Okay. How we doing? So we should talk about then, some of you said, oh, I don't remember distance formula. Well, we don't do distance formula for this because they're just two numbers. I don't have 2 points anymore. So let's talk about how, when something's in component form, how do we find the magnitude? So I already did how do we find the component form up here, okay? When something's in component form, how do we find the magnitude? So I'm going to do just a couple formulas. Magnitude or length. Okay, and we're going to assume, once again, all of this is under the title of we have a vector and its component form is v1, v2. Okay, so in general, we're going to assume my general vector is vector v. I know that's so original, vector v. And v1, v2 are its components. Okay, so if I asked you to find the magnitude or length, the way that I'm going to ask that is I'm going to just write it as an absolute value. So when you see that today, that just means to find the magnitude or length. And all we're going to do is we take the square root of the component squared. So v1 squared plus v2 squared. Okay. So just to be clear then, what would be the magnitude of this vector? If I said this was my vector up here, what would be the magnitude of vector 3, negative 8? Let's do it. Well, it would just be the square root of, ooh, purple is running out. Okay, that's 64, right? 3 squared is 9. 64 plus 9 is, so root 73. If it's not nice, you can leave it as a radical, but that would be the magnitude of that vector. It's really Pythagorean theorem. We're really going leg squared plus leg squared equals hypotenuse squared, taking the square root. So, okay. Ooh, we should talk about this. There's something called the zero vector. The zero vector is the vector 0, 0. Huh, what does that mean? Well, if it starts at 0, 0 and it ends at 0, 0, what is its length? 0. And it doesn't have direction, correct? So the zero vector, the vector 0, 0, just is the vector that has no length or direction. Okay, so we've talked about how to find the magnitude or length. We've also talked to how to do the zero vector. The last thing that we should do is just some operations with vectors to refresh your memory. There's no such thing as multiplying two vectors together. There's just no application for it. But it would make sense to add vectors. Like if I said, hey, there's an airplane and it's going this way. And then it changes direction and it decides to go this way. And I would say to you, well, what if I wanted to write that as one vector? Isn't this the same thing as starting here and then going to here? Don't I start at the same spot? In the end, don't I end at the same spot? Okay. So there's application for adding vectors together because they describe what we do with direction. But to add vectors together is pretty easy. We just use some addition. So we're going to do, if I can find my blank piece of paper, we're going to just add a couple together and subtract a couple to refresh your memory about that, because I know you did do that. All right, so this is our last example for today. So I'm going to give you vector u. So I'm going to tell you, let u be the vector -2, 3. So that just means it starts at 0, 0, and it ends at -2, 3. And I'm going to let v be the vector 5, 6. Let's evaluate some vectors. So first, we're going to write an expression for u plus v. And then how about -3u? And then finally, let's do 2u minus v. Alright, so first of all, u plus v, what I'm asking you to do is take -2, 3 and add on 5, 6. That's what that means. And I want a new vector. Well, vectors just describe how something is moving to the right and left and up and down. So if I want the total it moves to the right, can't I just add those two components together? Like it moves left 2 and then right 5. Well, what's -2 plus 5? 3. This is the same as moving a total of right 3. This vector is going up 3 and this one's going up 6. That's like a total of what? 9. Okay. I mean, I don't want to be redundant, but I just think if you understand what you're doing, sometimes it makes a little more sense. This just means -2, 3. So this is the vector -2, 3. Are you following that? And then from that vector, I'm saying if I would go up or right 5, 1, 2, 3, 4, 5, and up 6, 1, 2, 3, 4, 5, 6, that's the same as being over 3 up 9. That's all that's saying. Alright, there is no multiplication of vectors. There's no u times v. There's something called a dot product, which we'll get to later. But I'm not going to ask you today to do u times v. What I might ask you to do is take a number times a vector, -3 times u. What do you think you do for that? Yeah, it's like distribute. So the new vector would be 6, -9. Okay, and then putting it together. If I ask you to do 2u minus v, then I'm asking you to do 2 times -2, 3 minus 5, 6. So I'm going to just do piece by piece. What's 2 times -2? -4. What's -4 minus 5? -9, right? What's 2 times 3? 6. 6 minus 6 is 0. Okay, so that's just a little bit with vector operations.